So expression for frequency can be written like this. So frequency is equal to 1 by time period. So frequency is denoted by nu. This is nu, and pronunciation is nu, nu. Okay, nu. So it is 1 by T, capital letter T. So this is the expression of frequency. So from this we get SI unit of frequency is per second, and or 1 hertz or 1 hertz is equal to 1 oscillation second. Okay. So to obtain the expression of displacement, let us consider an oscillating simple pendulum. So oscillating simple pendulum is in its mean position right now, and when it displays, it makes an angle. It makes an angle with the position of the string when it is at rest. So let this angle be theta. Okay, so this angle we can say angle or angular displacement. Angular displacement. Okay, we are using displacement in most general form. Okay, so angle or angular displacement. Angular displacement, so the value of angle between a string of the bob or pendulum at different time intervals. Okay, so it is in mean position, and it is when force is applied on the body and there is a displacement takes place. So its motion can be defined in terms of angular displacement from the vertical. So displacement can take both values, positive as well as negative values. Okay, displacement is a vector quantity, so the value of displacement can be positive as well as negative. So using trigonometric ratios we can express displacement in both values, with positive as well as negative values. Let us consider it be a cos theta. Cos theta have both the values from +1 to 0 and from 0 to again -1. So it will be easy for us to take cosine of any angle or sine of any angle. Trigonometric ratio sine of any angle both gives us the value from 0 to +1 as well as from 0 to -1. So we can express displacement in terms of angle using sine as well as cosine trigonometric function. And in earlier episode I told that I have discussed that displacement is a function of time. Okay, so with varying time displacement value of displacement changes. So we can easily express displacement in the form of function of time. Displacement as a function of time for a simple periodic motion. Simple periodic motion, why I am saying that means in simple periodic motion or simple harmonic motion, motion repeats after regular interval of time. So function of displacement can be written as A. It is a constant value. Okay, A is a constant value multiplied by cos of angular displacement. It is angle theta. Let it be angle theta. So this angle theta can be expressed in terms of time also, because this is the time function. Okay, so displacement is a time expression or function. So in this side also we should take a value which is varying with time. So in simple pendulum, what is varying with time? The value of angle theta is varying with time as well as displacement. So we have to write this angle as a function of time. Okay, so how we will write? Angle theta is equal to omega. Omega is what? Omega is the angular frequency. Angular frequency multiplied by time t. So angular frequency, we have already discussed frequency. Frequency for linear motion is simply one reciprocal of time, and angular frequency is for circular motion. Okay, when we discuss motion in straight line, then frequency is simply expressed as 1 by time period, and for circular motion, frequency is described as angular frequency expressed by omega, and omega is equal to twice pi by t. That means in circular motion, what happens? If a particle is moving from this point, and after completion of one complete circular motion, it makes angle twice pi at the center. Therefore, this is the displacement of the particle, that is twice pi. Okay, so pi displacement is expressed as twice pi r. So we are assuming that the radius of the circular orbit r is equal to 1. Therefore, displacement is twice pi by what is t? T is the time taken by the particle to complete one rotation. So it is twice pi by t. So this angular frequency is sometimes also expressed as angular velocity. Okay, so angular velocity and angular frequency are same. So angular frequency and angular velocity can be expressed in same form. So when we say angular frequency or angular velocity, we can write omega is equal to twice pi by t, or sometimes omega is equal to twice pi nu. Okay, so why twice pi nu? This is 1 by capital T, isn't it? 1 by time period. So 1 by time period is what? It's a linear velocity, linear frequency. So angular frequency is equal to twice pi nu also. Okay, so when we multiply angular frequency or angular frequency with time, we get angular displacement. So angular displacement is what? Is a angle formed by the particle at the center. So we can say that the portion of the simple pendulum we are observing here is a part of the circle. That means this is what? This is the arc, a little portion of the circular path. So we can say that if we increase this part, it forms a circular circular path. So, and with radius is equal to length of the string. So angular displacement is equal to omega t. Hence, after every time interval t, motion repeats. Therefore, we can express displacement is ft is equal to ft plus capital T. Okay, which this displacement can be expressed in terms of this also. T is any variable time, and here capital T is the time period. This is the regular interval after which particle repeats its motion. Similarly, we can express displacement in terms of sine function also. Because why? A sine omega t also. Why? Because I already told that sine value and cosine value varies from -1 through 0 to +1. Okay, -1 value through 0 to +1. So this is exactly in similar to the motion of the pendulum. For some time it moves in positive direction, and after some time it passes through 0, that is mean position, and again by time small t, okay, again by time small t it moves or displaces in opposite direction of this. So let us take it as negative part. Okay, so as pendulum moves from one side to another, in the similar way sine and cosine values also varies or move from negative side to the positive side. Okay, or having negative value to the positive value. Therefore, now the displacement equation can be written as a cos omega t plus a sin omega t. Okay, so this is the linear combination of cosine and sine function. Okay, so displacement is the linear combination of cosine and sine functions. So this function is also a periodic function with time t. Okay, this function, displacement function, repeats itself or is a periodic function with the same period capital T. Okay, this T. So if this part always obey this rule. Okay, so this expression is exactly correct for this expression also. Okay.